Okay, so let's take the equation again. Y equals a sine, could have been cos, open bracket, b, open bracket, x minus c, close bracket, plus d, or h and k. And in the last part of the video, we looked at a and b, vertical and horizontal. And now we're going to look at c and d. So let's start by graphing y equals sine x. Y equals sine x. And let's do 4 vertical lines and 4 horizontal lines with a little bit farther. And from what we memorized, first of all, marking pi and 2 pi. And then putting a point at the beginning and at the end, and then halfway in between, and then at a y value of 1, and then a y value of -1 at 3 pi over 2. Excuse me, too low, at 3 pi over 2 at -1. And excuse me, and draw that graph. And we have our sine function. So we don't need to expand it and talk about period and amplitude anymore. This time let's talk about phase shift. So let's now do the graph y equals sine of x minus pi over 2. Well, that means we draw the same 4 vertical lines, same 4 horizontal lines. I'm going to go a little bit further this time. Well, this negative pi over 2 is, in big red, a horizontal translation equaling positive to the right pi over 2, the opposite of what you see inside the brackets. So looking above, I can take each of these points and move them pi over 2 to the right. Let me mark pi first. Let me mark 2 pi. Let me also divide 2 squares of pi by 2 and get pi over 2. And then again, I'm going to circle the point one more time in red. That point moves 1 to the right. So on the new graph, it is, here. And then if I take this point above, let's do the x-intercepts first, and I move it 1 to the right, it goes there. And the last one above there goes 1 to the right and goes here. And this point up here goes 1 to the right and it goes here. And this point down here above goes 1 to the right and here. And then I can draw that graph. And I could continue it if I felt interesting, or if they asked me to. And I've noticed that sine theta, I'm going to do in huge red, was shifted pi over 2, 1 square, if that's what your increments are, to the right. So I'm going to draw sine's box again above, and I'm going to draw sine's box again below. And notice, all I've done is shifted sine's box pi over 2 to the right, because we had a horizontal translation of pi over 2 to the right, because it said x minus pi over 2, and we do the opposite of what you see inside the brackets. So now we're going to take a look at another one. Y equals sine x plus 1. Well, remember, let's do it a little bit bigger this time, maybe 3 and whichever. Well, remember, big red, I'm going from the original, from sine x. And what I'm going to do is I'm going to move all the points up. So I'm going to do the points this time without circling them. I'm going to talk about the x-intercepts, and we just move them all up 1, depending on what your increments are. Mine are 1. And then the top point goes up 1, bigger, and the bottom goes up 1. And then we have our graph, sine x plus 1. And notice, sine's original box has now just been shifted up 1. So getting familiar with the way this perfect 4 quadrantal sections of this rectangle are, 1, 2, 3, 4, and the 2 rectangles on top of each other. And we're just going to be moving it around. So before, we saw that we were going to extend or compress the rectangle in different ways. Now we're going to be moving it around and doing the same thing. So remember, inside the brackets, in blue, in the formula at the top, C is horizontal, left and right. And D is, big red down at the bottom, a vertical translation equaling +1, having a D value of 1. So now we're going to put it all together, and we're really going to enforce this box model.